Assalamualaikum warahmatullahi wabarakatuh and good day. My name is Humanik bin Ismail. Today I will be presenting a lightweight convolutional neural network for rice diseases classification. Here is the contents of this presentation. We divided this presentation into five main group, which is introduction, related work, methodology, result and discussion, and lastly conclusion. As for introduction, rice holds significant importance as a staple group. This was also recognized by United Nations General Assembly in one of its resolutions, saying that rice is a staple of the more than half of the world population. Just like other living plants, rice plant is exposed to the pests and diseases, including fungi and viruses, which can lead to substantial yield losses and a decline in crop quality. The effectiveness of human vision approach lies on the eyesight, which is the common method used to identify pests and diseases. And this eyesight is susceptible to numerous limitations and also not scalable. The development of deep learning in recent years has opened a potentially revolutionary path for agriculture practices in rice disease diagnosis system, where instead of we use human vision, we use a deep learning to identify the diseases of this rice plant. So here is the problem statement, where we relies on human vision. As mentioned before, it has a few drawbacks, which is such as subjectivity and also varieties of observation. And the delay of the diagnosis of these diseases may lead to a major diseases where it grown to a worse scenario. And often in this scenario, we would use a pesticide excessively in order to contain or prevent these diseases to spread. And this excessive use of pesticide will lead to production and also environment damage. As for our objective, we have three. One is to develop a precise classification using a deep learning based network. Secondly is to enhance this network, optimizing it. And thirdly, to evaluate both of these network. Here is the related work that we refer to. First one, as you can see, is from Mahbub, where they develop a deep CNN with a support vector machine SVM, achieving 97.5% accuracy. Second, we have Hussein, where it used 3 pre-trained CNN models and achieved accuracy of 92.05% for dense net, 87.12% for efficient net, 82 and 58% for inception. Next, we have Amin, where his model able to achieve 97.4% of accuracy. We have Tejas Huini, where using it VGG16, the normal one and also the transfer learning one, and it able to achieve accuracy of 58% using the normal VGG16 and 72.2% accuracy using the transfer learning VGG16. Next, we have Gupta. We have developed a CNN models achieving 92.83% and 54.56%. While Sharma developed his own custom CNN architecture and able to achieve 90% of accuracy. Lastly, we have Krishnamurti, where with its simple CNN able to achieve accuracy of 84.75% accuracy. Here we have methodology. So as you can see in the screen, we have 4 main stages, which is dataset collection, image pre-processing, image segmentation, and also CNN transfer learning. For dataset collection, we get our dataset from Kaggle by Shazan Riaz. We downloaded 120 images for each of the class, which bring to a total of 480 images. Out of these 480 images, 400 images is dedicated to training and validation, while the remaining 80 images were allocated for testing dataset. For image pre-processing, we have applied a few processes. We have applied resize, color enhancement, and sharpening of the image. Then pass to our image segmentation, where we are using k-means clustering in order to isolate the specific area of interest with its background, as you can see in the image there, where we are using a blue mask. So we are at CNN transfer learning of benchmark model. So this benchmark model, we are using VGG16, where we modified the last three layers, which is the fully connected layers, the softmax layers, and output classification layers. We are keeping the convolutional block and modifying the last three layers. So this is one of the network. The next network is where we develop our own lightweight CNN model. In comparison to VG16, we only use 3 blocks of convolutional and keeping the fully connected softmax and also classification output. Here is for research objective. Basically, we are using all of this method to achieve our objective. Our objective one is to develop a precise classification system where we are using VGG16 transfer learning. Objective 2, we enhance the detection of rare diseases through the lightweight CNN model. And objective 3 is to evaluate both of these model. For result and discussion, firstly we look at the training progress. So this is for transfer learning model VGG16. We have 2 batch size, which is 30 and 20. For transfer learning VG16, we are able to achieve training accuracy of 85%. For batch 20 and for batch 30, we are able to achieve training accuracy of 83.33%. This is for training progress of lightweight CNN model. For batch size 20, we are able to achieve training accuracy of 98%. And for batch size 30, we are able to achieve 93.33%. As for testing a result, here is the confusion metric for the transfer learning model VGG16. For batch size 20, we are able to achieve 83.8% accuracy, while for batch size 30, we are able to obtain 75% of overall accuracy. For our lightweight CNN model, for batch size 20, we are able to achieve 90% of overall accuracy, while for batch size 30, we are able to achieve overall accuracy of 85%. So this is the comparison between the two models. The table above shown here is the accuracies for the batch size 30, while the table below shown accuracy of a batch size 20. For batch size 30, we can see that the proposed lightweight CNN model is higher than transfer learning, which we have 85% of accuracy, while the transfer learning VGG16 we only have 75%. For batch size 20, proposed lightweight CNN model, we have 90% accuracy, while for VGG16 transfer learning, we have 83.8%. So for both of the batch size, our proposed lightweight model is higher in comparison to VGG16 transfer learning. So in conclusion, the proposed lightweight CNN model is better than the transfer learning's VGG16 model. This also proves that with a simpler architecture, we are able to achieve a higher accuracy rate, and with this also the training time can be reduced without sacrificing the classification. So from this, we have the highest accuracy of 90% from our lightweight CNN model. I think that's it for my presentation. Thank you very much.